Welcome. In this second video for Unit 4, Lesson 10, we're going to use the law of cosines. We're going to use the law of cosines to solve for the side case. Before I get into this, let's go ahead and play around with the law of cosines. You remember the law of cosines is a squared equals b squared plus c squared. Well, here it looks like the Pythagorean theorem, right? Minus 2bc, just 2bc, cosine of a. That is, a side squared is the other side squared and added, minus 2 times the product of those two sides times the cosine of the angle between them. In this particular case, what's unknown are the angles. We don't know any angles, and so what we want to solve for is the angle, the capital A. So I'm going to go ahead and do some arithmetic here. I'm going to add 2bc cosine a to both sides. So a squared plus 2bc cosine a equals b squared plus c squared. And then I'm going to subtract a squared. So I get 2bc cosine a equals b squared plus c squared minus a squared. Now I'm going to divide both sides by 2bc. So cosine A equals b squared plus c squared minus a squared all over 2bc. Okay? And now we have cosine of A, and what we want to do is we want to find A, and if you recall, to get rid of cosine, to uncosine, we inverse cosine or arc cosine. So A equals arc cosine, that's cosine with a little -1, of b squared plus c squared minus a squared all over 2bc. And this is an alternate form of the law of cosines that you can use. You can use this law of cosines, this case, so where it's solved for the angle, to find the angles that you need. So let's try it. So let's use the law of cosines that we've derived, the version we've derived, to find x, y, and z. Okay, x, y, and z. So to find x, we're going to set up the law of cosines this way. We're going to say x equals the adjacent side, arc cosine first, arc cosine, of the adjacent side squared, 17 squared and 16 squared, minus the square of the opposite side, 14 squared, all divided by 2 times the product, 17 times 16. Do make sure you've got the things in the right place. It's easy to get these mixed up. Okay, in which case, let's plug it into Desmos. This can be a little tricky to enter here. So we've got capital X equals, got to use capital X because it won't let you use lowercase x, arc cosine, A-R-C-C-O-S, parentheses, 17 squared plus 16 squared minus 14 squared. Hold down the shift and hold down the shift, add caps lock down instead. Hold down the shift and press left arrow until all those numbers are highlighted. Hit divide 2 times 17 times 16. And we get 50.09 degrees. 50.09 degrees is x. Okay, and let's switch colors and let's try finding y. Same way. Y. Now we could use the law of sines at this point. Be sure to use a very accurate version of x so you avoid round-off error. But I'm going to go ahead and use the law of cosines to find y. So y equals arc cosine of, okay, the adjacent side, 17 squared plus 14 squared minus the opposite squared, 16 squared, all over 2 times the adjacent side, 17 and 14, is approximately, okay, let's go ahead and do this as a separate line. Capital Y equals arc cosine, ARC-COS, 17 squared plus 14 squared minus 16 squared. Hold down the shift and highlight, all divided by 2 times 17 times 14. Okay, and we get 61.24. 61.24 degrees. Now I could go ahead and use the law of cosines again to find z. I'm not going to. I'm going to go ahead and use the triangle angle sum theorem. So I'm going to subtract from 180. So z is 180 minus x minus y. So z is 180 minus x minus y. That's where the advantage of using the x equals and the y equals comes in. Capital Z equals 180 minus capital X minus capital Y. 68.66 degrees. 68.66 degrees. Okay, and 68.66 degrees. A good rule of thumb is to check using the triangle inequality theorem, which says the biggest angle goes with the biggest side. The smallest angle goes with the smallest side. The biggest side is 17. Is the biggest angle 68? Yep. The smallest side is 14. Is the smallest angle 50? Yes, it is. So it does match. That's just an extra level of checking to make sure you've done it correctly, because you're likely to mess that up if you mix up part of your formula. All right. Hope that helps.